Hello students, welcome to your favorite YouTube channel, the Engineers Class, and we are learning unit gravitation, and today is our lecture number 9 where we have to solve a numerical question that is presenting at your screen right now. As you are seeing the question, we have following data that is given on my whiteboard, and it is radius of Earth r equal to 6.4 into 10 to the power 6 meter, and height from the Earth's surface where the satellite had to revolve around the Earth each 2000 kilometer. So now we have to find the velocity required to revolve around the Earth surface for the orbiting satellite, and that velocity is called orbital velocity, and we have already derived the relation of orbital velocity in our previous lectures, and the link related to that topic is given in your description box. You can watch that video. Now we are ready to calculate the orbital velocity of the revolving satellite here. So, as we know, orbital velocity relates such as rg, where r is the radius of Earth, that is here, and g is gravitational acceleration. So we have radius of Earth as 6.4 into 10 to the power 6, and gravitational acceleration is equal to 9.8 meter per second square, but for the convenience we are putting 10 meter per second square in the place of 9.8 meter per second square. So we have gravitational acceleration that is equal to 10 meter per second square. After calculating it, we find the value in a such form, and when we terminate the decimal from this space, we will find the value such as 64 into 10 to the power 6 to the power half. Here, by cancelling the square root of 64 is 8, and the square root of 10 to the power 6 is 10 to the power 3. So the orbiting velocity of satellite at Earth's surface around the Earth is equal to 8 into 10 to the power 3 meter second, that is equal to 8 kilometer per second. Now students, we have another question, and we have to also calculate the orbital velocity of the satellite that is orbiting at a height h equal to 2000 kilometer. So what velocity is required to revolve the satellite around the Earth at a height h equal to 2000 kilometer? So we have to calculate the velocity that is orbiting of satellite around the Earth. Now I am wiping the whiteboard before calculating it again. As students, we have already derived another relation for orbital velocity in our previous lectures, that is orbital velocity is also equal to the under root Gm by R, where capital G is gravitational constant and capital M denotes to the radius of Earth. But in our question, the distance of satellite from the Earth center is not equal to the radius of Earth, and it is equal to the sum of radius R and height from the Earth surface, that is h. So we have to put up the distance here not as R, but it will be equal to R plus h. And again we have to find the value of Gm in another form. As we know, gravitational acceleration also relates as Gm by R square. So our Gm will be equal to the R square G. Now putting the value of product of G and M in this equation. So we have orbital velocity equal to Gmh R square G divided by R plus h. Now I am putting the numerical value of radius of Earth, that is R square. So we have to put here R 6.4 into 10 to the power 6 to the whole square and gravitational acceleration as 10. And the distance R plus h and radius of Earth, that is 6.4 into 10 to the power 6 and h as 2000 kilometer, and when we convert it into length as SI units, 2000 kilometer will be equal to 2000 into 10 to the power 3 meters, and it is equal to 2 into 10 to the power 6 meters. So after putting the value h equal to 2 into 10 to the power 6 meter, here 2 into 10 to the power 6 meter here. Now after calculating it again, 6.4 into 10 to the power 6 to the power square into 10, and here 10 to the power 6 is common. So after adding 6.4 plus 2, that will be equal to 8.4 into 10 to the power 6. When we calculate it again, we are getting the value that is approximately equal to the 7 into 10 to the power 3 meter per second. I hope you will understand full concept of this question, and we will meet again in our next videos. So student, please keep watching our videos regularly and don't forget to share our videos and comment please whenever you want any video related to your doubts. So we will meet again. Bye bye students.